graph y equal root x plus 2. Okay, so we know this should look like a root function. Our basic shape is going to end up like this. Now this plus 2 is going to change it a little bit, but we know this is the basic shape of our picture. Okay, there's several different ways to do this. One thing is we can always plug in some x values and get y values back. So we're going to try that first. Make an xy table. And I have to be very careful what I plug in to root x. Do y'all see that there's an issue with the domain? What restrictions do I have? Well, I cannot put a negative number under this root. So for domain, I take whatever is under my root, in this case it's x, and it has to be greater than or equal to 0. So I'm only allowed to put in x values that are 0 or larger. So I can plug in 0. I know what the square root of 0 is. That's a nice perfect square, so that's a good one. I'm going to put in 1. I know what the square root of 1 is. I'm going to put in 4. It's another perfect square. I'm going to put in 9, and I'm going to start with those. Okay, so if I put 0 into this, I get y equal root of 0, which is 0, plus 2, I get 2. If I put square root of 1, I get 1, plus 2, I get 3. If I do the square root of 4, I get 2, plus 2 is 4. Square root of 9 is 3, plus 2, I get 5. Now I can plot these. And notice, domain x has to be non-negative. That's what this means. Greater than or equal to 0 is not negative. So I don't really need this side of my picture. Okay. Okay, so I'll go over there. Make this be 9. Okay, and then 1, 2, 3. Okay. So I'm just going to plot these points. 0, 2, 1, 3. I'm going to go all the way to 4. 1, 2, 3, 4. 4. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 5. Okay, we connect this in a curve. That's beautiful. So this is y equal root x plus 2. That's one way to graph it. I'm going to get a new page and we're going to graph it a little bit differently. So, page. We're going to graph y equals square root of x plus 2. We're going to see this is taking this parent function, root x, we're going to shift it up 2. Because this 2 is added on the outside. Insiders lie, outsiders tell the truth. So this tells me to make it go positive 2. And if it's added on at the end, it's up and down. So let's look at the graph of y equal root x. If I have y equal root x, I see the domain is that x has to be greater than or equal to 0. Cannot have any negative numbers under this root. So again, I'm going to plug in 0, 1, 4, 9. Plug in 0, root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And I can plot this. As before, I don't need really anything to the negative, any negative x values. So just plot this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to plot this one in blue, I guess. So 0, 0, 1, 1, 4, 2, and 9, 3. And there's my picture. This is y equals square root of x. But this says I'm going to shift that graph up 2 units. So I'm going to take every point here, and this actually should touch, right? Every point here, I'm going to move it up 2. So 1, 2, 1, 2. That one's actually supposed to touch as well. 1, 2, and 1, 2. And I can connect this. And this is y equals square root of x plus 2. And we see the domain is x greater than or equal to 0. And what's the range? And let's talk about for y equal root x plus 2, we see the domain is x is greater than or equal to 0 because I cannot have any negative x's. I am not graphing over here, right? And the range, I see that if I graph this, I'm not allowed to plug in any x's smaller than 0. So I'm never going to let the graph continue this way. So if the graph continues along the same path, I see that y is going to be greater than or equal to 2. Okay, so there's the domain and range of that.